In today's lesson, we are going to learn about chemical equations, and this is one of the formulas. You're also going to be learning about states of matter.
Do you get this? Stop, leave me alone. Do you understand this?
Valence electron.
I wish there was a simpler way to actually learn this.
Atomic ion. Chemical formula.
Have you ever been frustrated or bored in your science class because you don't know what's going on?
Yes, all the time.
Well, we're here to help you. I'm Cindy, the science girl. And over here, we have one of my trusty lab assistants, Yesenia. And over here, and over here
Sorry.
is Robin, my second trusty assistant. He is our try guy.
Hi, I'm Robin. Actually, you arrived at a great time. I'm going to do my next great experiment.
Everything, and I do mean everything, is made up of matter and chemicals. And today, we are going to teach you about the chemical reaction.
And the properties of matter.
What's up? Robin here. Today, our first experiment is going to relate with pressure and volume. Some material we need: a candle, a glass, and some water, and a plate. First step, light the candle. Then put the glass, use the glass cover the candle. Let the show begin. Well, so how could it happen? Let's take a look about this formula. When the candle is burning, it cannot burn by itself. It needs a little helper, oxygen, and almost 20% of our air is oxygen. Inside of this glass, when oxygen burns out, pressure starts to decrease, and low pressure extracts the water to balance the pressure.
Okay, so it says here to add 1 pinch of C6H12O6 and 1 pinch of C12H22O11. Good job, assistant. You read my mind.
Hey Cindy, I'm kind of hungry. I think I have a sweet tooth.
Great, that works perfectly with our next experiment. How does ice cream sound?
What we will need:
Ice.
Sugar.
Salt.
Half enough.
Vanilla extract.
Plastic bag.
Step 1. In a little bag, 1/2 cup of half-half. Interesting. Next, 1 tablespoon of sugar. 1/4 teaspoon of vanilla extract. Then, In a bigger bag, we start step 2. Let me take out the air first. In the bigger bag, you combine 4 cups of ice in a large plastic bag. Step 3, add 1/2 cup of salt.
Just take the lid off.
Yes, very nice. Adding salt to water causes a freezing point.
Point depression, which causes the contents in the smaller bag to harden.
Now, we put the smaller bag into the big bag.
We close
Take
the
out
big
the
bag.
air.
Taking out the air. And my assistant will be putting in the bag into the sweater.
You then shake.
Shake it out. Get to the hub.
A few moments later.
There you are. Now,
I
let's
got the
see what we
spoons.
have. Let's see what we have made. As you can see, this is now ice cream, and we're about to eat it.
Chemical reactions. Here you go.
So here's your cup.
Just eat out of this.
Okay, we're just gonna get out of there.
Mmm.
Some in here. Yes.
This is actually really good.
Oh my god,
Can I have some? Dude, that's so good! We're gonna ice cream!
this is really good.
Wait, how did this happen?
Let's take it back to melting points. When salt comes into contact with ice, the freezing point of the ice is lowered. Water will normally freeze at 32 degrees Fahrenheit. A 10% salt solution freezes at 20 degrees Fahrenheit, and a 20% solution freezes at 2 degrees Fahrenheit. By lowering the temperature at which ice is frozen, we are able to create an environment in which the milk mixture can freeze at a temperature below 32 degrees Fahrenheit, therefore creating ice cream. We're starting to make some more for later, but right now, let's just enjoy this one.
Mmm. This is good, but I'm kind of thirsty.
Me too. Let's get some Coke. You're about to experience one of the greatest chemical reactions yet. But what do we need?
A paper. This paper is gonna stop the Mentos from going inside here directly. Then you're gonna need a little tube. Then you're gonna need some Mentos. After that, you're also gonna need a big, huge liter of Coke. Okay, so what do we do first? First, put the Mentos inside of the little tube. Like so. Then you uncap the Coke. Nice. Then, grab that. Okay. This part's gonna be a little tricky. Ready? Okay, ready? 1, 2, 3.
Whoa!
Hey!
I love Coke.
Nice.
Now, you enjoy your Coke.
Yummy.
Great. Let's talk about what just happened. It's not just Coke that reacts to the addition of Mentos. Other carbonated beverages will react as well.
Mentos has thousands of small pores on its surface, disrupting its polar attractions between water molecules, creating thousands of ideal nucleation sites for the gas molecules in the drink to congregate.
In other words, the porous surface creates a lot of bubbles, allowing the carbonated dioxide bubbles to rapidly form on the surface of the Mentos.
Then, the bubbles and their growth in size quickly cause the bubbles to leave the nucleation site and rise to the surface of the soda.
Bubbles will continue to form on the porous surface, and the process will repeat, creating a nice foamy result.
Yum. It can seriously mess with your brain. It's like a bunch of 100 songs, but I'll just get to the point because I'm not trying to take long.
See, there's things called elements and they can be combined. It doesn't really matter how good they're aligned. There's two main groups if you want to call them that, but the scientific name is chemical bond. You don't have to think about it. It's not that hard. There's this and there's that. You can write it on a card. That was the basic stuff. Now let me step it up. In case you didn't know, energy can't be created nor destroyed. There's a thing called flow of energy and it seems to be enjoyed. Heat flows with something warm, something cool. It makes sense because, I mean, who doesn't want to be cool? There's two types of energy reactions. There's endo and there's exo, and they're both some sort of action. The exo is energy out. In other words, heat is released. It can happen when you become deceased. Endo is energy in. In other words, nah, you get it. How do we measure it to be exact? There's two ways to complete the task. Joule and calorie to be exact.
If I keep going, I'd never stop. Just remember, even if chemistry makes you want to drop, keep going because there's so much more, so don't you stop. There's so much more to chemistry. It's basically a mystery and not a misery. Remember, there's more to chemistry than reactions and equations. This has been a pleasure. We out.